Welcome to aminacademy.com. In chemistry, let us discuss about stoichiometry in real life. Stoichiometry studies is a very important study in real life, in chemical factories and engine running like that. What is stoichiometry in engine? The stoichiometric ratio is the exact ratio between air and flammable gas or vapor at which complete combustion takes place. The stoichiometric ratio of combustion varies for various fuels and oxidizers. If the engine has less air than the stoichiometric ratio, you have a rich mixture because it is rich in gasoline. That means that stoichiometry studies tells us to correct ratio of air fuel ratio that must be supplied to the engine run properly. How is stoichiometry used in cars? Stoichiometry in its simplest definition merely refers to the relative proportion of components. For example, the stoichiometric relationship of steering wheels to the tires in a normal automobile is 1:4. Let's take a look at few examples of how stoichiometry is being employed in practical life. It's airbag design. That means in car front seat there is a airbag design is available in new model cars. That means it is safe for passengers when sudden brake is applied. Means it suddenly the airbag comes up and save the life of the passenger. For that how much air must be supplied suddenly, that is decision factor. That means airbag should open, that means it's come out at a sudden time. Second, rocket propulsion. Then lithium hydroxide scrubber, pharmaceutical industry, role in fast moving consumer goods, FMCG goods, and green chemistry, ecological stoichiometry. These are the main topics used in stoichiometry used in real life. What is stoichiometry important in the chemical industry? Stoichiometry is used in industry quite often to determine the amount of materials required to produce the desired amount of products in a given useful equation. That means stoichiometry is useful in industries to determine how the amount of material should be supplied to get a desired amount of useful things. How can stoichiometry be used in real life? Stoichiometry is the heart of production of many things you use in your daily life, like soap, tires, fertilizers, gasoline, deodorant, and chocolate bars, or just a few commodities use that are chemically engineered or produced through chemical reactions. Now we can discuss about stoichiometric air fuel ratio. The air fuel ratio is the ratio of the air and fuel supplied must be in correct level. That is, stoichiometric air fuel ratio is the ratio when the exact amount of air is present in the engine to burn the fuel present completely. This ratio is used to determine the perfect ratio of air and fuel to be used in an engine to get better mileage and a good life for engine. If we consider the ratio to be lower, that means more fuel available than air, then the mixture is called rich mixture. This mixture gives a lot of power and is good for engine life, but is not economical. That means fuel is more, as a lit of fuel gets burned in this process. If the ratio is high, more air available than fuel, then the mixture is called a lean mixture. This mixture is economical and burns less fuel, but in turns they are less efficient, can cause engine wear and tear. So we have to use correct stoichiometric air-fuel ratio for proper running of the engine. Now let us do an example problem to understand this stoichiometric ratio in engines. Example, cylinder in a car's engine draws 1 liter of air. How many milliliters of liquid of isooctane be injected into a cylinder to completely react with the oxygen present? The density of isooctane is 0.692 gram per milliliter and the density of oxygen is 1.33 gram per milliliter here. Air has 21% oxygen by volume. Now let us do this question. First of all, we find the chemical equation for this isooctane with the oxygen. Here it's given 2C8H18 is the gas and plus 25O2 is the oxygen, which gives 16 moles of CO2 gas plus 18 mole of H2O. Now we'll do this here given things. Volume of air, one liter. Oxygen percentage, O2 percentage, in air is 21% by volume. Now we'll do this problem very simply. Volume of C8 absorption 18 is equal to 1 liter of air and 21 by 100, because by volume it is oxygen is 21%, that is 21 by 100, and density of oxygen is 1.33 over 1 liter of oxygen into 1 mole of oxygen over 32 mole of, because molecular mass is 32 gram of O2 into 2 mole of isooctane and 25 mole of oxygen, because from the equation we are getting 2 mole of isooctane, 25 mole of O2 into 114.26. Isooctane molecular mass is 114.26. Then molecular mass of 1 molecular ratio 1 mole into 1 milliliter of C isooctane over 692 gram of isooctane because it is given here. The density is 0.692, 1 over 0.692, then which gives is here, which is equal 11.52 ml of 11.52 into 10 raised to minus 2 milliliter of C8H18. That means volume of isooctane, that is 11.52 into 10 raised to minus 2 milliliter of isooctane is needed to mix with 1 liter of air. Here what I have done so far is here we are explaining that stoichiometry in real life, that is it's more useful in engine design and air fuel ratio, as well as how the stoichiometry is used in cars and main areas of stoichiometric uses in your real life, and in chemical industry also it's useful. They have done. Then stoichiometric air fuel ratio we explained, and we have done one example problem and simply we solved. That means here the car, so 1 liter intake is 1 liter. For every 1 liter of intake we need 11.52 into 10 raised to minus 2 milliliter of C8H18. That is isooctane, that much we needed to complete combustion of the engine fuel. If you have done, please subscribe our YouTube channel.